Well, folks, welcome to week 6. Today is basically, review for the midterm. First, I'm going to talk about the midterm, then we'll do the review-ish thing. Oh, I forgot to update the slide online. It's 50 questions, not 54. I took 4 questions off because they were kind of repetitive. I will make sure it's updated properly at the announcement. It's closed book. Don't ask if you can have aids. No. No cheat sheets, no books, no laptops, nothing. When it's open book, I have to make the test harder. So therefore, be thankful the test is not hard. Well, harder. It's an hour and a half. Right here. Same time next week. It's worth 25% of your final grade. That's already been telegraphed. What's it cover? ER diagrams, obviously. That's all we did this semester. Entities, attributes, relationships, normalization, first through third normal form, database design type topics, indexes, and views. So essentially everything we took up till last week. Now these numbers are off because I forgot to update the slide. I literally updated the exam like yesterday, and I forgot to go update the slides. They're right here. And I went and picked them up on the way into class today. So I have the tests right there. But the breakdown is still proportionally correct. Actual fact, I have that elsewhere. No, I closed it. Darn it. I actually had it written out. And I forgot to save it. Anyways, rough question breakdown. ER diagrams, entities, attributes, roughly 13 questions-ish. Normalization, there's 14 questions-ish. Database design, actually, I think that one's closer to... the normalization actually is about 12 questions, and the database design is about 15. There's the difference. Indexes and views, there's five questions on those. What do you bring? Bring a pen or one or more. Make sure they work. Bring something to drink. Because I've had people start hacking up along and go, can I go get some water? No, you're not leaving the room. Water, coffee, tea, I don't care. Just make sure you have something to drink. Cough drops, candies, whatever it takes. Snot rags, also known as tissues. If you're not feeling well, please bring some of those. You don't get to leave the room to go to the toilet, go grab a wad of toilet paper, and I'm not bringing any in. So, if you're feeling a little runny around the edges, make sure you take something in, blow your nose. And people are like, why do you bring up these topics? Because I've had people. I've addressed this before. It's happened in class. I do ask you to go to the bathroom before the start of the test because I can't deny you going to the bathroom. But I also don't have someone to escort you to the bathroom. And that'd be kind of weird, depending on, which bathroom you're going to be using. Even then, it's still kind of weird. The good news, though, if you really forgot something to drink and you really need to get something to drink, I can watch you right there. There's a fountain right there. So this room's good because I can watch you go to the fountain. Not so bad. I wasn't sure where the fountain was. Now I got it confirmed. Okay, other important information. If you have a Kyle accommodation, make sure you book it. I cannot give you extra time. It's like, arrive on time. It's important. Because if you arrive after the first person has left, you don't get to write. Now, that last point is only half right, because originally this was Scantron, but I don't have time to wait for Scantron this year, because at 11 a.m. on Friday, I'm leaving town for a week. And so I need to actually finish my grading Thursday night. So your test paper is your attendance though, so there's no sign-out sheet. You finish the test, you bring me the test, you leave. Done. Since I have to finish all my grading on Thursday, next Thursday, your grade will probably be inputted in Brightspace by the end of the night. I don't have a choice. Friday at 11 a.m. I'm leaving town. It's a 450-kilometer drive. There is no internet, no Wi-Fi, no cell reception where I'm going. Pretty much. I'm disconnecting from life for 7 days. Disconnecting from life and connecting with my fishing rod. So I'm just going away for a week. I haven't disconnected for years, so it's time. Now, like I said, your test paper is that. Normally, the reason I say normally ask you to answer on the test paper and on Scantron. There's no Scantron this time, so answer on the test paper. There are multiple guesses. You just circle the right answer. Away you go. Very important. Make sure your name is on the test paper and that it's legible. By legible, it means I can read it. I don't care if your signature is legible, but please write your name on your test paper the way it shows up in Brightspace. Or at least a close facsimile. I cannot read it if it's written in moon runes. Insert Asian character set here. I also can't read it if it's in Cyrillic, and I can't read it if it's written in Farsi. So does it make a difference? Latin language, please. Okay, so that's the breakdown. Like I said, I'll make sure that the right information is put on Brightspace for you guys. The question breakdown and everything. Just the right numbers this time. Now, what I'm going to do is I'm going to do an example for you guys of normalization from start to end. Make this a little bigger. Perfect. And so I pull off the board. I really wanted to be right there. That's what we have to do. We're gonna have to make the font a little bit smaller. Okay, and then drag it over just a little bit smaller. Okay, there it fits. Okay, so what I'm going to do is I'm going to do a complete normalization exercise right to the point where it goes from normalization to diagram to physical diagram. Start to end. But basically, it's literally everything I taught you guys this entire semester in one go. So you get to see how it all fits together. Because some people were like, yeah, we learned all these topics, but how does it all fit together? Seeing it happen from start to end, which even nowadays, this doesn't happen as much as it used to. You'll still get cases where you're being dumped a big pile of data and you need to do this. Therefore, here's an example. All right. So
you can't be turning on the lights at the fronts.
yeah, I was running both. Oh yeah, that's this.
Don't recall. There no wasn't a button in the bases.
Oh right, this is the room where there's just 3 second switches. You can 3 separate things. Every other room, the button turns everything off. Okay, so we've got ourselves a sample set of data. Currently, it is not in first normal form because when things are in first normal form, you have no repeating group of columns. Congrats, we don't have that in this. There's no repeating group of columns. We also have to have the candidate keys identified. Therefore, when we look at this data, we can go, okay, so which combination of columns allows us to uniquely pick a row with the current setup? So, yeah.
You say, oh wait, no, never mind. I was gonna say employee number and grade A, but I see for Jim does, that does.
I take this one. No, like that.
Yeah, but it's two different people, so they'll have two different, employee numbers.
Exactly. It's got two different employee numbers, two different rates, essentially rate IDs, and what they're doing similar work. Maybe, I don't know, the invoice number, but the problem is that we may have the same person on one invoice twice, in this case. So in theory, you probably should be three columns. But right now, with the data we have, the combination of those two columns lets us basically find any given thing. So we know this employee with that invoice number for that hour. This employee, again, different invoice. This one here has two different invoices with the same rate ID. And this guy here, report about technician gets paid nothing depending on the others. Or we charge less than as we get so a lot less. Rate ID. Okay. Now, depending on how you want to look at it, the data can be sliced a few different ways. But currently, this combination of columns will allow us to match. So we now theoretically have our canyon keys. So what we're going to do is we are going to go write it all out again, first normal form. How many markers I get to go through today? That's number one right now. First normal form. And we're just gonna call this table invoice for now. Okay. And we've got to go employee ID, employee number. We're just going to try to stay consistent. Employee number, name, email, rate, ID, our rates. All right, and we are going to put in our underlines like this and like this. All right, so we've accomplished first normal form. In theory, we can find any row of data with that combination of columns. Now we need to start identifying our partial dependencies. And this is where I'm talking about earlier, where we could slice and dice the data slightly differently depending on how we decide to do this. Okay. So when we come across the columns here, we look at the data and we go, okay, the name, is that dependent on the entire key? Yeah, the employee name, is that dependent on the entire primary key? Does it have anything to do with the invoice number? No. Okay, so therefore, this one's a partial, right? So we're gonna draw right here for now. And that's not a very big color. It's not standing out enough. So the name and the email, let's do them both at the same time. And they're both depending on this guy here. So we know this is a partial dependency. The project description depends on but it also kind of depends on employee number. So it's fully dependent, right? But actually, when I designed this set of data, I noticed it was actually a little vague on purpose so that you guys can think about it a little more. Because you guys actually think about this. Okay, so when we look, okay, let's back it out then. Let's go look at the rate ID. Okay. Right now, if we look at the rate ID and the rate, it seems to be tied to specific tasks. But it also seems to be tied to specific people. So where do we decide this goes? It does. Depends on both primary keys. Okay, so therefore, so these guys here, and I guess this guy here is dependent on the entire primary key, depending on how you want to look at it. Had these markers for a long time, so it's letting me thin out the herd a little. Oh, this was supposed to be. So what we've identified here is we basically have two entities right now. The thing is that we could theoretically include the rate ID as part of the primary key and suddenly our data changes. The implications of the data changes, but it has nothing to do with finding individual rows. So some people would argue that you could include the rate ID as part of the primary key, and some people would say, no, you don't. It would be up to interpretation. Because you know what, in the end, it's all going to look the same. It's just at which stage are you going to break it down? Okay, so we identified our full dependencies and a partial. So now we need to break that down. So we're going to go to NF, and we're going to have employee, and we're going to have invoice. That's right. And I'm actually going to transfer my arrows to this side. So we have our name and our email that's dependent on the employee number. And rate, hourly rate, project description of the hours. Are dependent on the entire primary. Okay. We're going to give you guys a legend. With my terrible handwriting. Partial dependency, full dependency, like such. All right. So now we're going to fill it out. So we got our employee, which we have our employee number, our name, and their email. Well, I can't bold, unfortunately. It's underlined, okay? Well, yeah, it's different plots will grade on different things. Okay, and now we've got our, we're gonna have actually the employee number again. Because it is participating in the entire key, because the rest of it has no partials, right? So employee number, invoice number. Then we go rate. ID. Hourly rate. Project description. Hours. Okay. And this is the primary key. We also know that the employee number is a foreign key. Okay. All right, so we've established second normal form. Once again, the definition of second normal form is it's in first normal form.
And there's no partial.
And there's no partial dependencies. We are now in second normal form. We've eliminated some anomalies, but not all the anomalies. Now, the next anomaly we need to identify, and I'll come back over here, is our hourly rate is dependent on the rate ID. But the rate ID is not part of the primary key. Therefore, this is a transitive dependency. This depends on this. I come back over here. I'll put it on the board here. As such. And that's our. Transitive dependency. Okay. And how do we fix our transitive dependency issue?
Create a new entity.
We break into a new entity. So currently, we're about to go to third normal form. We know how to break it down. I am now going to turn off the projector because I don't need it. My laptop doesn't have fitness. Still recording. Oh, the magic switch is hidden by the screen. No, I just realized it. Okay, so now we are going to go over here and do our third normal form after you erase just the lines. Not going to go over them more. Okay, 3.5. So we have employee. Our employee ID. Name. And email. We have, let's call it rates. We have our rate, ID, and hourly rate. That's good. And then we have our invoice. For need ID. The rate, no, sorry, the velocity. Invoice ID, rate, ID. Or it's just not there. Project description and hours.
The employee and what's in with numbers nowadays.
If they're, they're ID, so I just gotta go grab my markers to.
No, it's not.
Right?
Is there their numbers, there's employee number and invoice number, not employee ID or invoice ID.
Yeah. Sorry. Because eventually in my brain, when I'm designing these database tables, I would be converting those to. To by the word ID instead. Okay. All right, so. Primary key, primary key, primary key. Red markers looked at. And these guys are foreign keys. Yes.
Invoice number, there is no column that is on that. That's
No.
why I'm. Where's the seven?
In theory, we, at this point, if we really wanted to be just right, we'd actually, if I had a date column, then we'd have invoice with its date and the invoice would be its own table and we have invoice lines. Didn't have a date on this one, just had invoice numbers. Therefore,
Yeah, that makes sense with our lab in the example, there was like the order and then the order details, which I guess was like the rows or specific details.
but because the data I gave you guys to work with didn't have a date, the invoice is literally, the invoice number actually serves almost no purpose. Other than being a key. So, all right, so we've now normalized. And I'm gonna take pictures of the board before I start. If anybody wants to take pictures of the board, here's your chance. You can stand up. I will kind of try to tell something, but you know, in case something goes horribly wrong. Because things do go horribly wrong. Which are, you know, you guys are not. She's gonna be smart, she's gonna come up and take. Portrait on a widescreen thing. It goes suddenly right here. Landscape.
My friend's whole wedding and he gave you some shit for that.
Did you actually hit your friend?
No, you're not, it's just fine. I'm sure I know 10 minutes sooner that I was the wedding photographer.
Oh, okay, that's fair. But the fact you didn't pair a wedding with a phone is questionable. Okay.
The wedding was English.
Okay. I'm not saying that's wrong, I'm just. Okay. So the reason I'm taking pictures is I'm erasing this board. Because there's not enough boards in this room for me to keep going. Everybody took their pictures? Okay. I do have the recording, but you know, quality? Questionable. Questionable forward. So you can, you know, follow along the logic. Well, when I was teaching this C lecture hall, the big C, the two big C lecture halls, the one downstairs, if I remember right, has like whiteboards on 3 walls.
Oh,
Like, you can just-
with like the sliders.
Well, it's got the sliders too, so it's got sliders up and down, but it's also got some on the other 2 walls, so you've got like 6 whiteboards. I'm like, please put me in that room. They're like, you have 20 students. That room's designed for 140.
Well, it's empty anyway, so like.
I know. Okay, so now we are going to do our conceptual diagram. There's only 3 tables, so we're going to put in our 3 boxes. Okay, we. Rates. Invoices. I really should space this out. Okay, from diagrams, from relationships. Because we already know what the relationships are, we're just going to draw them in. All right, an employee can have many invoices. This table's in the way, this guy can see on the left.
You could probably lower it. Press a button and it goes down.
Yeah, maybe. You know how many of these don't work in this demo? Good bro. All right, so an employee can belong to many invoices because we have that in the data. But in theory, the employee doesn't participate in all invoices, so it's functional. Any given invoice entry is only ever for one employee at a time. Yeah, they can have multiple lines, but they can only be on one line once. And obviously, it's participating as part of the primary key, so it's mandatory, which makes this an identifying relationship. All right. After the relationships, I'll actually do the attributes. Okay, same thing with the rates. Now, each rate can be used more than once, but each line only has one rate. The thing is that the rate does not participate in the primary key. So now you have to decide, is it mandatory, is it not mandatory? Does it make sense to actually do an invoice without the rate ID? No. It's like you're putting something on an invoice saying, bro, worked on this, it's free. I'm not an artist. I don't work for free. I don't work for exposure. No should ever want for exposure, I'm just saying. Okay, therefore, it's actually going to be mandatory, but it's not identifying because theoretically the invoice line could exist without the rate. So it's not going to be an identifying relationship, it's just a normal relationship, but it is going to be actions. The rate could be used multiple, so this was optional. So the rate is mandatory. Each invoice line has one rate. It has to have a rate. But the rate's not necessarily used. They can have a new rate that's never been used, or rates that are no longer used, so the rate is optional to the network. All right, so we've got our basic table. We're going to put in our attributes now. We've got our employee. So on that, employee number, and other cases underlined. We have the name and the email. They tell you stuff drawn by hand. No, really. I just have to draw them by hand. Okay, now we got our rate ID and our hourly rates. Such. And then we have our invoices in the end, which now on the conceptual side, you normally don't include the form fees. You just don't include. The fact that this is an identifying relationship that's mandatory will basically says, hey, by the way, for this table, we're going to need this, but we do that at the physical stage. At the conceptual stage, we just put in, say there's just two invoices. So in this case, we would have invoice number and the project description. What was that?
Did they put some bullet whiteboard or something there?
It's dented.
Oh.
Somebody got angry. And then we got hours. Like that. I was getting that. And same thing with the retail. Okay. So this is our third normal form turned into a picture. We have lost nothing so far. We are, we could take this and now explain it to someone that's not technical for what the relationships are in. You probably, for someone non-technical, you probably want to just put this as a normal relationship, not an actual special version of it, but you can still take this, explain to them what the symbols mean, and actually more or less get the message across. So now we're going to go to the physical diagram. And I have research talent. All right, so again, we have three entities. That means we're going to have how many tables? 3 tables. All right, so we're going to start with our employee table. And this is where I'm going to apply naming conventions. I tend to follow snake case naming conventions. Why? Because they work in all database servers. Lowercase, everything, underscores instead of whatever. Okay? So we have the employee number, their name, and their email. Okay, now we can draw this line like this. And then send this out over here. All right, our employee number, probably an integer. So we'll say int. It's also our primary key. The person's name, in this case, we didn't specify whether it's, the name's broken down to multiple pieces or not, it's just a name. Therefore, we're gonna wanna make it pretty chunky, gotta handle all the names out there. All right, so probably it's gonna be a varchar. And more than 50. People have these lot like Hispanic names. Or French Canadian married women's names. 50 is not enough. Let's go with 150. It's gonna get chunky. So you won't have a full name. So you just want to have lots of early. It's a varchar. So 150 is fine because it's only ever going to use the amount of space that's in there. It's not always occupying 150 bytes. Or depending on what code pin it is, 300 bytes.
So it's better to put more.
Always. Whatever you think the worst case scenario is, at 30%. Yes.
If you show to use the varchar 2 by 5.
So that some people will do that, but the issue is that you should try to make the data structure reflect reality. Like I've seen cases where I get a database and everything was varchar 255 all the way down. Yes, it'll work. But they had varchar 255 for postal code. Canadian postal code is 6 characters, 7 if you want to include the space. Australia has 5, 6 if you include the space. Some parts of the world, it's 6 digits. The reality is you don't need 255 characters for 6 digits. So you want to make the data structure represent quality to what is actually in the reality. And of course, you want to give yourself a little bit of extra room, just for the safe side. Email. I told you guys the story already. So varchar 150 minimum for email. Pretty sure I told you guys the story. The one about when I inherited a database where the email address is only 70 characters long, and somebody tried to type in an email address and it didn't work because it was too long. Yeah, just weren't paying attention. Yeah, it's stuff. It was a Franco woman's name, long first name, hyphenated last name, the whole department name after the email address. It was really, really bad. All right, so we got our employee table. Now we have our rates. And we have our rate ID. And we have our hourly rate. Again, that's going to be an int, and this is our primary key. Now for hourly rate, we probably want to use a numeric or decimal. You could use a money, but the problem is the money always rounds to 2 decimal places. It has its losses, as in you're going to lose some fidelity. Realistically, most places the hourly rate is like 150 bucks an hour, and the story there's no decimal places, but you never know. So we're going to use a decimal. Some people use a float, some people use a double, but do you really need an infinite number of decimal places? Why would you use something that takes up that much room if you don't need it? So numeric and decimal are interchangeable. They're the same thing. They're aliases to each other. Some database servers will call it numeric. Some of them call it decimal. And Oracle calls it number. Because Oracle only has one numeric data type. Everything's a number. Whether it's an integer, a float, or money, it's a number. But there's ways to make it be other things, but it's a number in all of them. So the hourly rate, we're going to say it's a numeric. Well, when you get first with the numeric, we have to say how many digits total, and then how much precision do we want. So realistically, for the hourly rate, we really only need 2 places of precision. So we want to have a 5-2. 5-2. 5, 2. That's not scrambled again. And I'll explain to you the 5-2 in a second. I did talk about it in class, but I'll go over it again. Okay, 5-2. That's the 5-2. So it will hold up to 999 and 99 cents. Depending on your database server, you have to tell it whether it's unsigned or not. So we want it to be tell out negatives or fine. Same thing with the integers. But we're sticking with generics here, so it's numeric. So now we've got our invoices. Go ahead. Oh, should we add not nulls to this? Sure, we could. Honestly, the numeric should be not null, so let's go ahead and not null. Valid question. Just no, it's not null. That one's a primary key, so it's not null by default. Sure, the name can be required, so let's go ahead. Totally valid question. So that's not null. No. So we have our invoices. A few more fields now on this one. We have the employee number. Following rules. The invoice number. The rate ID. The project description. And hours. Now, employee number has to be the same name type as its parent. It's going to be named. It's part of the primary key. It's also a foreign key.
So internally, you need to specify primary key for the key.
If you're using the tools, when you drag and drop the relationship, it'll create the foreign key for you. But since I'm doing it by hand, depends on the tool. So the invoice number, also an integer, it's part of the primary key. The rate ID is an integer, and it's a foreign key, and it's not null. For rate ID is not it's not primary key. So it's a foreign key, and it's not null. So we said it wasn't going to be null, right? Primary keys by default are always not null, so we don't have to worry about that. Project description. Based on the data we had, it just looks like it's just like a small summary, not an actual description. So we get to use his favorite thing, a Vericar 255. He gets to have his Vericar 255. We have to decide if it's not null. Should it be required? Would you like receiving an invoice where it says you owe me this much money and it doesn't tell me what it's for? Therefore, realistically, this should be not null. And then we have the hours. And then we have to decide how we allow the hours. Are we doing hours only in full hours, half hours, quarter hours? And that will determine our level of precision we need on our number. Quarter hour is usually pretty common, you know, depending on, like, if it's like a law firm, they'll charge by the quarter hour, by the half hour. Most software development firms will charge by the half hour, rounding up as applicable. They never round down. FYI, never round down.
A lot of jobs I had, they round off your time clock to the nearest half hour or a quarter hour.
Yep, yeah, like McDonald's. McDonald's runs up and down. So for hours, we probably want to do quarter hours. So if we do quarter hours, we need how many decimal places? 2. Also in our data, nowhere did we ever see huge sets of numbers like 20 hours on this, 25 hours on that. Because realistically, when you look at it, how many hours are there in a month? So work 5 days a week, and say 7.5 hours, 37.5 hours a week, times 4. Somebody please pull out a calculator.
160 work weeks for this, but I think
160, 155, something like that. Because there's always stat holidays and stuff. So let's go 150 hours. 37.5 times 4. 140, 150. So 150 is good. So if we need 150 plus 2 decimal places for precision, we need the exact same thing as this. So we go there, like 5.2 for precision. And I'm gonna draw a post on this guy because we are doing physical diagram. And now we have our physical diagram, which brings us literally to everything other than views that was taught to you guys this semester. All as one long process. So yeah, this is Coco a, oh, shoot. And this should probably not know.
When I say primarily a great identifier, are we showing this or the normalization?
Well, that's just what we normalized.
Yeah, I'm talking about the first, the column, the first normal or.
Oh, this is, we took the third normal form and then diagrammed.
it's a third.
Yeah, I don't understand why you're looking at, priority to rate ID because.
Because in the data that you were provided, you could find an individual row without it. If we had more rows of data and suddenly we started having overlap, then we could probably add the rate ID. And suddenly we'd have a third value. Or maybe we'd have something else like a date on the order or something, and it would change the structure. Just the data will change depending on how the data will change the result. That's all there is to it. The data changes the result. But yes. I wasn't talking. Okay. All right. So, any questions about what we just finished doing? Okay, go ahead.
So this order.
The order of what?
Because
No, technically, no, you can put them wherever you want. It's depending where you work, they may have preferences. No, not the platform. The employee or the person that gives that, the person you're hoping at one day will give you money to do this kind of stuff. They will, they will have standards. Like the place I used to work at, we required that all keys be at the top of the table when the database is new. When the database is then being modified and updated, you can't do that because some database servers won't let you change the order of the calls. Therefore, like MySQL lets you do it, Postgres does not. So with MySQL, you can actually go and alter table, add column, and you can tell it after this column, and it'll actually insert it. But other than Oracle, Postgres, Microsoft SQL Server doesn't let you do that. So, so as a rule of thumb, a lot of places prefer that at the initial design that all the keys are at the top. and then the rest goes down below. After that, it makes no difference. You try to do it in a logical order. Like you wouldn't put first name, email, last name. You go first name, last name, email. As much as you can.
In the invoice table, is the phone number, directly in this table?
Yeah, and in the invoice table, yes, it's primary key and a foreign key.
That's it, it's not a primary key.
It is. It's both.
But
It's a primary key. So it's a foreign key that participates in the primary key. This example has all three kinds of keys in it. So you've got a compound key, you've got just a foreign key, and you've got a foreign key that participates in the primary key. So you've literally got one of everything.
Okay, so it's compound key, so the employee number and the invoice number
Yes,
together.
is the primary key.
Okay.
Then you're saying that.
Yeah, because here you don't see it in this diagram. But if we well, you don't see, well, it is because this is identifying, so it's carried down, but you don't see it on this entity because the relationship is saying it's there. Okay, now we're gonna take some more pictures.
Until like the same employee has two jobs on the same invoice and then you still.
At that point, you probably need to do something else.
Yeah. But that wasn't in that one.
That wasn't part of the data.
Yeah.
And the point was that I was trying to get when I designed this data structure, I was one, to get you guys to think about the data. And two, we end up with a table that has like compound key and foreign keys in it. But the foreign keys in the whole thing. So it's an actually awkward example, but it covers a lot of the different topics. And yeah, so that's the end. Next week is your test. But it's multiple guests, so you don't have to do this on paper. Like you guys don't have a practical assessment, so. But take the guys that I just teach before you guys, because they're the level 1 course that I have right before you guys. They're gonna have to do this as a practical assessment. They're gonna have 2 hours to do this.
Oh, you're doing the level 1 version management course.
The level 1 database course that you guys took, a CST8250.
Oh, but they're actually the one.
Next semester,
Oh, okay.
the next semester, this course is getting a practical assessment of this stuff.
But
But the midterm test will be half the size.
Yeah.
Because there's gonna be less questions on the theory because they're doing the practical application. Or at least that's what I've been told to do. A little bit more precise.